Hello everyone. Today we'll be discussing about relations and functions. So in this video I'll be covering about the basics of what a relation is and why do we study them, and in a later video I'll be trying to cover about functions. So this will be mostly important for board students and for the students of classes 11 and 12. So without a further ado, let's start. So in linguistic terms, when we say about relations, what do you mean? A relation is a connection between two objects or things, any two objects. But in mathematical sense, when we say about relations, it will be between two sets. So I just assume that every one of you have a good knowledge of what set theory is, what sets are, and then you have come to study about relations. So starting with, if I start with two sets, suppose I have a set A, suppose I have 1, 2, 3, these are the elements, and okay, I have the example over here, A, 1, 2, 3 and B, A, B, C. Then before going to relations, we need to understand what a Cartesian product is. So the Cartesian product of two sets A and B are, it is denoted by A cross B, is 1, A, 1, B, 1, C, 2, A. So it's nothing but all the sets of first elements coming from the first set and the second elements coming from the second set B. So all the first elements belong to the set A and all the second elements belong to the set B. Okay. Now please don't confuse here. These are elements and this is the name of the set. So this A, this B is not the same as this A and this B. These are set names and these are set elements. Okay. A relation from a non-empty set A to a non-empty set B. Now the sets must be non-empty, because if a set is empty, that means it doesn't contain anything. You cannot make a relation into a vacuum or an empty space. So you need something to make a relation to. So is a subset of the Cartesian product A cross B. So you have understood what a Cartesian product is. Basically these are like our graphing points in a two-dimensional graph. We plot points, right? So it's similar, x-axis and y-axis, right? The subset is derived by describing a certain relationship between the first and the second element of the ordered pairs A and B. So these are called the ordered pairs. Each of these pairs are called the ordered pairs. Why ordered? Because there is a certain ordering. That is, the first one comes from this set, the second element comes from this set. So it is ordered. You cannot have any element in A cross B as like B, 2. So this will be an element of B cross A, not A cross B. A cross B will contain 2, B. Okay. In B cross A, the first element comes from set B and the second element comes from set A. And in A cross B, the first element comes from set A and the second comes from set B. Right? So let's see an example. Example 1. P equals 4, 9 and 25. It's just a set, for example, okay? And Q is -5, 3, -3, -2. That's 1, 2, 3, 5. Okay? Let R be a relation defined as follows. Now we'll define that certain relationship. Okay, because all the elements of the Cartesian product won't fit into the relation. Okay, in certain cases there will be, but in general, no. There is a certain idea, there is a certain relationship between which the sets are connected with each other, right? See, R equals x, y, this ordered set such that y square is equals to x. So I have taken y square is equal to x. Now y belongs to the set Q. Please note here, y belongs to set Q. So y must be any of these elements, and x belongs to set P. So x must be any of these elements, right? Okay. So now let me just go on taking all the elements from here. See, if I take -2, okay, -2 from here. So -2, if I take -2, then -2 square is 4, which again belongs to P, so this element belongs to R. In the same way, you take 2, and 2 square is 4, again it belongs to R. -3 square is 9, it belongs to R. 3 square is 9, it belongs to R. In the same way for -5 and 25. But in P cross Q, you have many more elements. I have not written everyone. There are many more elements, right? So basically what you can see is that R, the relationship, is a subset of the Cartesian product P cross Q. Okay. Next, some important definitions related to relations. So we have the domain of definition of a relation, the range, and the codomain, right? The domain of definition is the set of all first elements in a relationship R from a set A to a set B is called the domain of the relationship R. Okay, so if I have these elements here, so the domain consists of 4, 9, 25. Okay, so the domain of R here for this example, okay, domain of R is 4, 9 and 25, which is equals the set P. Okay, so the set P is called the domain of the relation R in this example, example 1. Then the range, the set of all second elements in relation R from a set A to a set B. I have not mentioned non-empty, they will obviously be non-empty, is called the range of the set, range of the relation R. Okay, so here the range will be range of R is equals all the second elements -2, 2, -3, 3, -5 and 5. So, and the codomain is the whole set B is called the codomain of R. This for definition we are taking B, but in our example we have mentioned it via Q. So Q or B doesn't matter, it's just the naming. So this, for this example, this will be the codomain, this set, whole set Q. So we have already seen that Q is -5, -3, -2, 1, 2, 3 and 5, right? So you can see that the elements 1 is not present in range. So clearly range is a subset of codomain, right? So we have the domain of definition, we have the range, we have the codomain. So range is a subset. It might be proper subset or it might be an improper subset also. Not directly improper, but it might be wholly contained or it might be equal to the codomain. That's what I mean to say. So finishing with this video, we have an important note here. Let NA equals P. So what NA and NB is, these are called the cardinalities. Cardinalities. So what are cardinalities? Cardinalities means the number of elements of a set. Elements of a set. So it, in different books it will be denoted by like this. Suppose a set A, it will be denoted by like this, or card of A, or you have N of A. You can denote it anyhow. So let the cardinality of A is equals P and the cardinality of B is equals to, that means number of elements of A is P and number of elements of another set B is Q. Then the total number of possible relations from A to B is given by the total number of possible subsets of A cross B. That is the total number of possible subsets of Cartesian products, right? Cartesian product of A and B. Okay, that is from A to B. So if the relation is from A to B, now if I am defining from B to A, then I'll consider the Cartesian product B cross A. And in this case, I'll consider the Cartesian product A cross B, right? So the total number of relations is 2 to the power P into Q. 2 to the power P into Q, okay? 2 to the power PQ. That means 2 to the power NA times NB. Sorry. So, for example, let me just erase this part. For example, if I have one set, say A is equals say 2, 3, 4 and 5, and B is equals say 4, 9, 16 and 25, and then A cross B contains 2 to the power PQ subsets. So NA is equal to P is equal to, here it's 4, right? There are 4 elements here, and also here NB is equals Q, there are 4 elements here. So there will be 2 to the power 4 times 4 equals 2 to the power 16 total relations that can be defined from set A to set B with this definition, with this cardinality. There might be different elements, but the total number of relations will be same, that is 2 to the power 16. So with this, I conclude this video, and in the next video, I'll be talking about functions, a basic intuition into functions, and how we can generalize them and understand them in our day-to-day life. Thank you.